I am Dennis Vasin from EasyChain team. I'd like to present you GreenTrust, marketplace for renewable energy certificate. It allows you to issue and trade RECs in safe and decentralized way. Unfortunately, most energy worldwide is produced from non-renewable sources. Lack of irreversible ecological damage is the most important part of sustainable growth. It's important to have a way of supporting renewable energy producers. One way is to allow them to issue renewable energy certificates. Renewable energy certificates, or RECs, are a market-based instrument that certifies the bearer owns 1 megawatt hour of electricity generated from a renewable energy resource. We've developed a marketplace that allows producers to issue renewable energy certificates in the form of NFT tokens. It allows free trading of such tokens. Our solution architecture allows to minimize manual intervention in verification of actual amount of energy produced. Let's talk about solution architecture and business workflow. We'll begin from the simplest use case and continue to more difficult ones. There is three main roles involved in certificate issuance process. First is supplier, renewable energy producer such as solar power plant. Next is regulator, a governmental agency responsible for certificate issuance. And the last is verifier, an independent agent validating certificates using mathematical models. Certificate issuance request is created either via a manual request from user interface or automatically using IoT sensor data. After a successful verification of amount of energy produced, certificates are issued, signed by regulatory agency and transferred to supplier. If produced energy amount cannot be verified automatically, request is moved to manual checked for expert. Experts can then proceed to issue RECs or reject their issues. Requests can be split to multiple parts. RECs for a partial amount of produced energy can be issued automatically, while parts that can not pass automatic verification can be processed manually using above-mentioned process. On the trading part, once RECs are issued, owner can mark them tradable, and initially owner are of course the energy producer. Once tradable, they will become available on the marketplace to purchasers. Certificates are purchased using GRT tokens, which are internal tokens of our system. Let's talk about network topology. Blockchain nodes can be placed in each of the involved parties' infrastructures. But note that placing a node is not a requirement, as many parties can share the same node, much like in Ethereum using an infra nodes. Suppliers can integrate data from its energy source via an IoT gateway to be sent directly to blockchain, and verifiers can do that as well. Each certificate is represented by an NFT token with unique ID and single owner at a specific moment in time. Ownership transfer rules are set in smart contracts, and there is also a marketplace for them. We believe that this project brings significant advantage over a traditional centralized renewable energy issuance model. It allows certificates to easily cross borders. Each certificate is immutable and have full traceability history in blockchain. And using blockchain allows us to trade certificates on decentralized exchanges, bringing instant liquidity to them, which should help renewable energy producers to accumulate more funds. Everyone can become a validator, which makes the system more resilient, transparent, and secure. What we've actually built during a hack, we've created two smart contracts, one for certificate issue request and another for certificate and its trading. And we've developed a complete solution using Waves Enterprise blockchain testnet. We've deployed a prototype IoT gateway that allows us to collect data from sensors, measuring energy production. The whole project was developed in close collaboration with Russian regulator, Sovetrinka, and we've got a full approval for our business workflow from them. And lastly, we've created a web-based DApp, which allows us to demonstrate how the whole system works. And we've used a whole bunch of technologies, with the most important ones being Waves Enterprise and EasyChain. Waves Enterprise is our blockchain of choice for this project, while EasyChain is our solution, allowing for low-code smart contract development with visual modeling. Otherwise, we've used Java for IoT gateway and React Redux and JS stack for frontend. Why not use Ethereum or other blockchain? I mean, by no means mining Ethereum is green, so that's out of question. And since we are working in a highly regulated industry, using a public but permissioned enterprise blockchain seems to provide the most beneficial trade-offs between openness and freedom on one hand and being regulated and permissioned on the other hand for all involved parties. Our future developments from economic standpoint may include cross-chain bridges to allow REX to be traded on DEXs and using prediction market for verification. And from technological standpoint, it's important to switch to MQTT for all the IoT data processing. And now we'll show us the demo, and that's our team. So thanks and demo time.